Sometimes in science, you do regular experiments. You test things out in laboratories. But sometimes you do what's called a thought experiment. In other words, rather than actually doing a physical experiment, you imagine things in your mind and use your imagination plus logic to prove a theory true or false. And that's exactly what Galileo did when he was proving that all things fall at the same rate. Before that, the general theory was that something heavier would fall faster than something lighter. So in this case, if you have this big, giant, heavy mass and this tiny little light mass, the heavy thing will fall faster than the lighter thing. And Galileo, just by thinking about it and applying logic, not using stopwatches or anything, just applying logic, proves that this cannot possibly be a true scientific rule. So here's what he does. He says, well, you have the original rule is that the heavy thing will fall faster than the light thing. Okay, fine. Now he's going to add a little twist. A little twist. He's going to connect these two things with a very light string. Now the question is, will this combined thing, the heavy mass tied to the light mass, will that fall faster or slower than just the heavy mass by itself? Well, on one hand, you could say that these two things tied together form one bigger mass that's heavier than just the heavy mass. So the two things together is obviously going to weigh more than just the one thing by itself. So that this combined system of the heavy mass tied to the light mass is going to fall faster than the heavy mass by itself. So that's one conclusion. But hold on. You could also look at this differently. You could say that this light mass is going to fall slower than the heavy mass. So if you tie the heavy mass by a string to the light mass, this light mass should actually slow the heavy mass down because the light thing falls slower, the heavy thing falls faster, so that's because they're tied together, the light mass is slowing it down. So that theory, that heavier things fall faster, predicts both that the heavy mass by itself will fall faster and that the heavy mass by itself will fall slower. Obviously, that's impossible. The original theory has a logical contradiction in it, so just by thinking about it, Galileo can prove that theory false. Now, later on, Galileo also proved it experimentally false, but the key thing is this: without doing a single experiment, just by imagining this in his mind, Galileo proves this theory false. Interestingly, later on, many other scientists are going to use these types of thought experiments to really put their theories together, or sometimes as the entire basis of their theories. Einstein's theory of relativity is heavily or nearly entirely dependent on a major thought experiment. Even Darwin's theory of evolution heavily depends upon thought experiments. By using just logic and imagination, we can do a whole lot. You don't always have to use a physical experiment.